Hello guys, this is David Pinto here back, and I'm very happy to see all of you together again. And today we're going to be discussing about logarithms. We're going to understand the meaning of a logarithm and how to solve some question logarithm. And also, I like to show you how to prove all the rules that we know about logarithms. So please keep on watching and enjoy the video. So guys, as we said before, we're going to be talking about logarithms here. But before starting with the lesson of logarithms, we have to pass through something called laws of exponents. Now guys, with these laws of exponents, I'm just passing through them a little bit fast because I think you have studied them before. And they say, our first one says that if I have a power m times a power n, then I will get a m plus n. Now this is our first rule. If I have a power m times a power n, I get a power m plus n. It's the same of saying if I have 2 power 2 times 2 power 3, then according to the rule I'm going to get 2 plus 3, which is going to be 2 power 5. And this one can be proved. Let me just prove it a little bit here. So I have, let's say I have 2 power 2, it's the same of saying 2 times 2. If I have 2 power 3, it's the same of saying 2 power 2 power 2. Now if I have here 2 power 2 times 2 power 3, it's the same of saying 2 times 2 times 2 times 2 times 2. If you count how many 2's we have, I have 1, 2, 3, 4, 5. So my answer is going to be 2 power 5. So now you see that, let me write this 5 properly guys. Now you see that it is the same answer. Our second rule guys, it says like this: if I have a power m divided by a power n, my answer is going to be a power m minus n. Now this can be proved by this. Let's say I have 2 power 2 divided by 2. Let's say I have 2 power 3 divided by 2 power 2. According to the rule here, it says my answer is going to be 2 power 3 minus 2, which is going to be 2 power 1. 3 minus 2, 1. Now, but how can we prove it? If I have, let's say, 2 power 3, it's the same of saying 2 times 2 times 2. If I have 2 power 2, it's the same of saying 2 times 2. And if I have 2 power 3 divided by 2 power 2, it's the same of saying 2 times 2 times 2 over 2 times 2. If you see here, this may cancel with this and this one may cancel with this. I remain with 2. But remember that 2 power 1 is equals to 2. So if you see guys, I have got the same answer here. So please, these things should be on mind in order to understand logarithms. The third rule says that if I have a power m, but all this one is with another power, let's say power n. So my answer here is going to be a power m times n. There is another rule, the fourth rule, that says that if I have an under root here, let's say of an under root of m, and inside I have a, I can represent it by means of a power 1 over m. This is the same of saying this one. This rule is going to be, if I have an under root of m of a power n, so the answer is going to be a power n over n. So guys, this is something very important to understand about it. And also I can write another one, which is going to be number 6. If I have a over b, now this is the same of saying b over a, but writing an inverse. So I just wanted to remember you these rules here so we can continue with our class or lesson of logarithms. Now guys, suppose that I have a. Now I have a, let's say power b. let's say this one, a power b, I assume I left a power b to be equals to c. A power b is equals to c. Now, mathematicians say that if you have a power b is equals to c, you can simplify by saying that logarithm of base a, this a remains here as a base. This c should come here, and this b comes to this side. Now this is the base of a logarithm, this is the foundation of a logarithm. If I have a power b is equals to c, then we can say that logarithm of c base a is equals to b. Now let me write it properly. Say a power b is equals to c. All this one is the same of saying logarithm of a is the same of saying, if you apply logarithm here, this one should come here and this one should come here, but you should apply logarithm. There is something called rules of logarithms. Okay? Our first rule says that if I have logarithm base a of a, now a is here the same. My answer is going to be 1. My answer is going to be 1. You may guys be wondering why. It is very simple, because if we convert it into our normal form, this is known as the logarithm form, and this one is known as the exponential form. If I change it, then I'm going to say that a power 1 is equals to a. And this one is correct. A power 1 is equals to a. Any number power 1 is equals to the same number. Now my second rule, guys, says that if I have logarithm of base a power 1, let's say now I have power 1, then my answer is going to be 0. You may be wondering, guys, why is it true and how can we prove it? If we change it to an exponential form, this one should come here, so we say that a power 0 is equals to 1. And this is true because if you remember that any number power 0, you get 1. If you have, let's say, 10 power 0, you get 1. If you have, let's say, 10 million, let's say you have 10,000 perhaps, power 0, you get 1. Now guys, there is another rule, a third rule. Our third rule says that if I have logarithm base a of b, but this b is power, let's say, power d. Logarithm base a of b power d. This is the same of saying d logarithm of b base a. As you can see here, this one came here down. This is our. Now guys, there is a fourth rule that is called changing base. Now the changing base says like this: if you have logarithm of base a of b, this is the same of saying logarithm of b base 10, here is base 10, over logarithm of a base 10. Now this is a very important rule for us in mathematics, that we usually use this one to simplify logarithms. And you may be wondering, how is it true? I would like to prove it to you. I'm going to prove this equation, this rule here. If let's say we have logarithm base a of b, okay? Logarithm base a of b. Now let this one here to be equals to, let's just say x. You know, we can let anything to be we can let this to be x. If I change it to exponential form, I will get a power x is equals to b. I think you guys understand what I did here. A power x is equals to b. Now, upon apply logarithm base 10 both sides. So if I apply logarithm base 10 both sides, I get logarithm of 10 of a power x is equals to logarithm base 10 of b. I just applied logarithm base 10 both sides. According to the rule we studied here, the third rule, this x should come here down, so I get x logarithm of a base 10 is equals to logarithm of 10 base 10 of b. Now guys, let's divide this let's divide both sides by logarithm of a base 10 divided by logarithm of a base 10. So this one will die. These two here died, so it means that x is equals to logarithm base 10 of b over logarithm base 10 of a. But remember something, if we come to our equation here, see that x is equals to logarithm of b base a. Now since this equation is equals to this one, we can equate saying that this one is equals to this one. So we can end by saying that logarithm of b base a is the same of saying logarithm of b base 10 over logarithm of a base 10. So here we have proved our rule. So we can say hence prove. After proving this one here, there is some other rule that we may prove. For example, this one saying if I have logarithm, let's say base 10, let's say there is something called, if I say logarithm base 10 of a, it is the same of saying logarithm of a. When you see here that there is nothing, it's empty, we assume to be 10. Most of the time we assume to be 10. Even in these cases here we did. So I can write to say log of b over logarithm of a. It's the same because the 10 is not a must to be put there. Also guys, there's another rule that says that if I have logarithm, let's say base a of m times n, this one is the same of saying logarithm of a of m plus logarithm of a of n. Now this is another rule that you have to know and to understand. There is another rule that says that if I have logarithm of a, m, let me write it properly, m divided by n. Now it is going to be logarithm of a minus logarithm base a of n. So now guys, this is the other rule you should know. Well, after knowing all these, guys, we're going to be solving some questions. Let's say you are asked to find the value of x. The value of x. So you're given that first logarithm base 2 of x is equals to 2. You are told to find it. So the first step you have to do it, you have to change it into exponential form. Remember, this is in a logarithm form. So you change it into an exponential form. These two should come here as the power. 2 power 2. You're going to get the value of x here. So you can say that x is equals to 2 power 2 is the same as saying 2 times 2, which is 4. Let's say you're given another question. Logarithm base 5 or 125. You are told that this is equals to x plus 2. Okay guys? Now you have this equation here. The first thing you can do is to change it into an exponential form, the same as we did here. So this one here, all of them should come to this side, so I get 5 power x plus 2. Should be equals to this one, 125. Should be equals to, okay? But guys, if you remember, 5 times 5 is equals to 25. And 25 times 5 is equals to 125. So we can say that 5 power 3 is equals to 125. Means that 5 power x plus 2 is equals to 5 power 3. 5 power 3, which is 125. Hence you can say that this and this one here will die. You remain that x plus 2 is equals to 3. Then you can say that x is equals to 3 minus 2 because this one comes to this side changing sign. So I say that x is equals to 1. Thank you very much guys for watching this video, and I hope you increase a little bit your knowledge in mathematics. Sometimes this topic brings problems or troubles, but please guys, keep on doing questions, never give up, and you're going to do it very well.